Hello, everyone. My name is Temidayo. I'm a Microsoft Certified Data Engineer and also a Microsoft Certified Fabric Analytical Engineer and also a Database Administrator. So this is our solution for the Microsoft AI Fabrics AI Challenge. So this solution was done between me and my friend Olujare Dada, who is also a Microsoft Certified AI Engineer and also a data scientist. So the title of our solution is Change Data Caption Data Architecture with Open Source Technology and Fabrics, right? So the solution comprises of streaming technology, AI, pipeline, and data engineering. So this solution has been broken down into three major components or three major aspects, right? So we have the core data engineering here. We also have the data engineer and also the analyst. I also have the data engineer and also the data scientist. So I'll explain everything how it goes end to end from the architecture itself, right? We also have a documentation which we're going to be submitting on our GitHub repo, right? So this our presentation is going to be broken down into two different parts, right? I will explain the data engineering part, and my colleague and my friend Dada will also explain the AI part of how the solution works. So we're going to merge both videos together and we're going to submit it to you. So this is just the first part. So just enjoy with me as I explain everything end to end. So assuming we have an application, right? So we have a web application. So we're trying to from the web application, right? A software engineer has built a web application, right? So there's a back end, there's a front end. So we, the customers, we interact with the front end, right? While the back end is where most of the magic happens. So whenever information are being sent, we have what we call a connection string that sends data to Azure PostgreSQL database. So we're using the Azure PostgreSQL database. So we're trying to use all the components that was actually suggested in for the competition, right? So the database we're using is actually a flexible database, right? We're not using an instant, we're using a flexible database server for Azure Postgres. So we have a connection string. So the connection string basically comprises of both the host name, username, and the rest. So the way the solution works is we're trying to do like a real-time CDC approach for database. So what happened now is we have an application, right? An application from here sends data to Postgres, Azure PostgreSQL database, right? And at the same time, we've also set up what we call Debezium. So Debezium is an open source CDC data capturing that works between database and Kafka. Because why are we using Debezium? Because we can send data from a database to Kafka topics directly. Because Kafka topics has to be two types. It has to be serialized and it also has to be a JSON or Avro format. So what we use now, we use Debezium, which is an open source CDC approach. So what we basically did, we connected Debezium to the Postgres database, that's the Azure Postgres database. So what's going to happen now is as soon as the data are being inserted into the database, which is on Postgres, right? Change data capture captures those changes in real time and sends it to Kafka topics, right? So when it gets to Kafka topics, so we're using the Docker, we're containerizing everything in Docker, we're using a local, our local machine, right? It's actually hosted in a virtual environment, a Windows virtual environment. So as soon as the data gets to Kafka topic, right? So we have two consumers, right? So we have one consumer that sends the data to Elasticsearch. Elasticsearch is more like it's a vector database. It's a open source vector database that usually stored that helps for reading data faster. So we're using an Elasticsearch, right? So we're inserting those data real time into Elasticsearch. Then we have Kibana for visualization. So this part is actually done. This is more of the engineering part, right? Because we want to see what we're visualizing, we want to see what kind of data is entering into our database, right? So we have a Python script that picks those data from the Kafka topics and inserts it real time into Elasticsearch index. So you can also Elasticsearch index Elasticsearch index is just like our Cosmos DB, right? So you just have like you create your index, you send your data into it. So it's just like Cosmos DB, just like MongoDB, any kind of database. But for this, I'm using Elasticsearch, right? Database, which is inside of Docker, and also have Kibana, which is for my visualization. So this is basically how the whole core engineering part works, right? So at the same time, because for machine learning algorithm, right, we have they need data in a format that they can easily read. So what we also did was, okay, so that we have two scripts. We have one script that consumes data from Kafka topic and sends it to Elasticsearch. We also have another script that consumes data also real time and sends it to Azure Data Lake Gen 2, right? So we created a container in our Azure Data Lake Gen 2 where we send data to this. I will explain how everything works. And then we have our Fabrics pipeline that picks those data incrementally and puts it inside a file path in our data, in our lakehouse in our Fabrics lakehouse, right? So we have a pipeline that will create the fabrics that picks the data incrementally and sends it to the lakehouse file path, right? Also, if you come over here, right, if I come to this other path, you see that I see some other things we did, right? So we did what we call a change data caption. So recently I know Fabric just added the CDC approach for event stream, where you can actually connect to things like Postgres, things like SQL Server, and pick data real time using a CDC approach, right? So that's the same thing we did here, right? We did a CDC approach to pick data from Azure Postgres comes. So now the source that produced the source that sends data to event stream, which for some of us that are coming more from the Azure background, like myself, I'm coming more from the Azure background, right? I use more of event hub, stream analytics, and the rest, right? So I would just say event hub and stream analytics are almost the same. Right. So what's going to happen now is what is producing data now to my event stream is going to be my Postgres CDC approach, right? So that's the source CDC approach for Postgres, right? So data comes to the CDC approach. That's the CDC event stream comes here. Then the data is being sent to event stream, which acts more like event or basically the same thing, right? I capture the data real time and I send it to my KSQL database, which I'm going to use for my querying using the KQL for querying, right? Which is developed by Microsoft for real-time stream. Then I send those data to Power BI report, which I use to do real-time analysis. So it's more like, I'll call it near to real-time analysis, right? So I do near to real-time analysis, and also have my data activator for, which works more like alerts in Power BI. So this was basically the general overview of the entire architecture, but I'll go into it in depth and explain everything one after the other. So it's just a simple architecture. It's actually being used in the real world, but I just added some more features to just make it capture the entire Microsoft ecosystem, right? So why is it open source technology, which is Kafka, Debezium, Elasticsearch, and Kibana? Why is it some enterprise technology, which is on Azure Postgres database, also on the Fabrics ecosystem, and also why is it using Azure Data Lake Gen 2? And also we have some security, some governance, and some other features we've added into this. So I will head to the next session and show you how everything works end to end. Thank you very much. Okay, welcome back. So we're going to be starting the entire project now, and we'll show you how everything works end to end. But before I start, I was just going to show you documentation we did, right? So we're also submitting the documentation. So we've done a well-detailed documentation that explains everything end to end. So it's going to help us to, so for the judge and for the Microsoft people, you can actually easily replicate this solution with just following the documentation. We've actually made a very, very well-detailed documentation on our GitHub repo. So you can see we have all the codes here. So from the environment variable for the security, we also have some of our images, we also have our README files, we have the consumer script, we also have the Docker compose file, that's our YAML file, which we set up all the different images we used for this project. We also have the Procedure scripts and also some requirements, right? So if you look at the documentation, where we explained everything from the introduction, project requirements, the architecture, the different sections, the prerequisites. Also, you have to be open-minded, actually. The provisioning, setting up everything using, so all the tools we use are things like Azure CLI, because I'm coming more from the Azure background, right? So I use a lot of Azure components and everything. So from how to set everything to how to set up service principle to how to connect using SaaS token, basically everything is well detailed. Also setting up variables using the Azure CLI. Also, one thing also is for these Postgres SQL database, we're not using an instance, so we changed it to flexible, because it's flexible that works for CDC approach, and also we also changed the logic. So it's something called the WAL. So for the WAL level, we changed it to logical. So there's replica, there's logical. So change to logical, right? So these are some of the things you have to see. So everything is well detailed and well explained, from setting up the Docker components to environment variable to pipelines. Like if you go through the entire documentation, we've explained everything. So it's like you can easily replicate the script from the producer. Basically everything. We also showed you when data is entering the database, how we connected the Belgium using Postgres, setting up everything, right? Also setting up the Kafka topic, listing out all the Kafka topics, Also creating an index in Elasticsearch. I'm just going to like run through all of these. So the script, the confirming script, setting up basically everything. Oh, sorry about that. So my hands are a little bit moist. That's why. Okay, so you're also writing some script to view the data, checking out the data, also setting up of Kibana for our visualization dashboards, just basically everything. This is discovery. Also, this a little bit of visualizations, right? Okay, also getting the SaaS token, that shared access token from Data Lake Gen 2, connecting you to it. As you can see how the data is also being sent into Data Lake Gen 2, right? So I'm always mixing up Data Lake Gen 2 and Lakehouse most times nowadays, right? So also setting up the event stream, also doing everything right. So you can see this is the CDC approach. So one thing I noticed, so that's part of my recommendation, which I'm also going to give, right? So one thing I noticed, so this is setting everything up. So one thing I noticed was actually in the slot area. So there's actually a conflict, right? So it worked, right? But I want to just explain something. So I gave a more like a warning over here, right? So one thing I noticed when I was doing the CDC approach using Fabrics, right, was because I've already set up a CDC with the version earlier with the version with my Postgres database, right? So when I also tried doing that same CDC with Fabrics, so there was a conflict. So what it means that I had to now create another Postgres server again for me to be able to do that. So it was actually costing me a lot, but after I did it, I just had to just delete it, right? So this is just something I noticed and something that like maybe Microsoft can actually look into more, right? So this feature is amazing in the enterprise approach. The only issue I found was Postgres database does not support multiple slots, right? So that's one of the things I saw, right? And it was actually causing a lot of conflicts, and that's just something I just kept there. Okay, maybe it's something that you can always review and make more updates into it, right? Also, so what I had to do, the other alternative, and I now created another script that sends data directly to event stream now. So I now use the custom application. I will explain all of this. I'm going to share all of this work. I'm just giving like an overview. So creating custom scripts. Okay, so what else did I have to get the connection string and also the event hub name. So for some of us that are already used to using event hub, it's still the same approach, right? Testing the script, you can see the script, also using KSQL, using event house for KSQL database. That's sorry, KQL. Sorry, I'm always mixing KSQL. So KSQL, you use it more for Kafka Confluence, right? For consumption, right? KQL, Crucial Query Language, that's for Microsoft. Sorry, I tend to mix that up a lot. Sorry about that. And also, you can see some of the features. Open the have the reports, visualize it, write some query. That's KSQL project, and these are the columns I want to see. Right. So for me now, I use a lot of logic app a lot. Sorry, log analytics a lot, right? So I write a lot of KQL for analytic and logs and reading of logs and everything. So do a little bit of visualization, create a pipeline using Fabric. So we're picking this data from. So because my data analyst wants the data to be more like in a file format. So that's why I passed it through this approach also, right? So getting the connection, creating the pipeline, picking the data. And now you can see the data now is now in our Lakehouse user folder as a JSON format. So for this part is more of my colleague, my friend, Dada, right? So he did more of the AI aspect from the OpenAI keys you gave us during registering for the competition itself, and you can see everything, code walkthrough, everything is listed. So the idea for this is that you can pick this up yourself and do it yourself. So that's the whole idea. So that's why we broke everything we did. We actually documented everything, so you guys can actually replicate it yourself and build it yourself. So I will just so you can see all the walkthrough, all the tests of the AI. Well, this part will be explained more by my friend Dada, right? So I will now go into the code itself and show you how everything works one after the other. So thank you. Okay, so welcome back. So now let's not go into the code aspect now. So I'll open my Visual Studio Code, right? So in my Visual Studio Code, you can see everything I used for the entire project itself, right? So the environment variables, the consumer script, basically everything that was basically used for the entire project is here. So first of all, let me show you the Docker Compose file itself, right? So in the Docker Compose, these are our different services we're using. We're using the Elasticsearch, right? We're using Kibana, which is for Elasticsearch is for our database. Kibana is for visualization. Zookeeper is for what we use to manage Kafka brokers. We also have our Kafka. Also, we're using the Belgium for our CDC approach, and basically everything. And so we also have a Belgium UI also for the visualization part of the Belgium. I also created a bridge that connects all the services together. So if you see my Docker, if I go to my Docker, right? If I go to my containers now in Docker, I have two containers right now. So this is the one I'm currently using, which is Fabrice Kafka Database. So if I open the container, you see there are multiple images, which I have over 6 images here from those services. 1, 2, 3, 4, 5, 6. Right. So let's now go to the code itself. Everything is working as expected. So if I go to the code itself, sorry, if I go to my code myself, right? So what I'm going to do now is I want to show you how everything works end to end, right? So let's start from the first. So let's now start by creating our producer. So this producer basically sends data. It picks data from an API, right? Because I don't have a mobile application. So I'm picking data from an API from a website itself, right? If I scroll down a little bit, I don't need to really break. I've actually explained the code well the data. I don't really need to start breaking out all the entire code, right? But I'm picking data from an API. So I'm basically picking data from an API, and we're going to insert the data into a database, right? And everything, you can see most of the security, I'm using what we call environment variables. So all the securities are actually here, right? So, but I won't show you this one. I actually kept it on the GitHub, but I actually removed all the credentials, but the one that is here is actually the real credentials. I might not want to open this aspect because these are my personal credentials, but this is where set all the security, set everything, picking data from an API. The database URL are actually be set from the environment variable. So I won't open this aspect because of security purpose, right? So let's say I want to now run the script. Let me just run the producer script. So this one now picks data from the URL and insert it into the database. So we're using that URL more like as an application itself, picks the data from the URL, pushes it into the database, right? So this is the name of the URL. So if I open this image, it's called random user URL. Let me just copy this and show how it looks like on our. So if I open a URL here, if I paste it here, you see the URL now. They're just random data you can see. So anytime I refresh, it changes female, changes male, female. So that's random. So they're more like dummy data. So they're not real life data. So I'm not using any sensitive data right now. So what I will do now is I will run the script, right? So let's say Python producer. So for the Python producer, I just press enter, right? So it should start running, right? So now it's just connecting, and let's give it a couple of seconds to run, and you can see now it's now inserting those data. So it's total of, now one row has been inserted with 12 columns. So if I check my database, so I'm using this, so now I have a total of 2,944 rows. So let me just run the script again, and let's see how many is here now. You can see now it's increasing now to 2004, and it will keep increasing like that, right? Okay, so let me show you the data in more like a tabular format. So let's just select all, delete, 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 delete. Okay. Let me just limit it to 20. So it won't, same limit to 20. So I won't take much of our tables or everything. So enter, select all, semi. Sorry about that. I didn't look at that. Select, okay. So So it might take time. Okay, so it didn't take time because I was thinking that because I'm using the same data. Most times you use a view. Actually, most time you use a view. So I think we have a view created. Let me see. Yeah, so I have a view. So most times rather than me connecting to this, I'd rather connect to a view next time. So let me just put the view here. So I won't affect the production data itself. I'd rather be picking data from the view itself, not from the production data. That's from the production table itself. So it's better that way. Let me just run this again and see. Okay, cool. Right, so amazing. Okay, so run this again, and okay, awesome. So most times I prefer reading from the view. So I don't want to tamper with the table because that table is more like your production table, right? That's where data is being sent to. So you don't affect those parts. So after this part, right? So now I can see my data is coming here. real time. So let's now go to the Belgium, right? So if you go through the documentation, I've shown you how to set up the Belgium. So this so this is the Belgium. It's actually running, right? You can see it's running, and something is being connected to it. So if I'm trying not to open some sensitive information, but this is my Belgium currently running, right? If you go through the documentation, I've explained how to set it up, how to provision the Belgium and everything. But one is connected, so it's currently running at the moment, right? So what I'm going to do now is um I'm going to read my what do you call it now? How to check out the um the Kafka topic I currently have. So if I go to my same Visual Studio, right? So this one is currently running. Let me just open another. So I want to check out all the topics that I currently have on. Let me just clear this, right? So if I run this, so this basically helps me to list out all the topics. I said Docker compose, right? Execute Kafka topics. So list out all the topics in the Bootstrap server, which is 921. So if I run this, it's going to it's going to list out all the topics currently in my Kafka. And the one I'm mainly concerned about is this, right? The Belgium Connect Fabrics user, because this was the one I used in setting up my what do you call it now? The Belgium, right? So the connection name is called that's dev underscore connect. If you look at it here, right? Dev underscore. So this is like the connection name. So and if you come here, you can see it's fabrics.user database. So this is basically, so this is the connection I'm more concerned about, right? So one other thing I did was, okay, now, since I know that data is now being sent to the database real time, and the base owner is consuming those data and sending it into Kafka topic, I can say, let me use the command line interface to actually visualize if data is actually being sent to the Kafka topics, right? So I'll just paste another script here. So this script basically now, if I paste it here, right? I'm trying to consume data that is being sent to the Kafka topic. And the name of Kafka topic, I see the Belgium Connect .fabrics.user. That's the name of this one here, right? So I want to consume it from the beginning. So if I run this, it will tell me if I'm able to consume data in Kafka topic. That's if data is being sent to Kafka topics, right? From the Belgium, and you can see awesome. So basically now it's telling me that, oh, a lot of data is being sent to Kafka topic, meaning that, oh, so this is correct, right? So now the next thing I want to do now is, okay, this one can stop anytime. It's just showing me that I'm actually consuming data. Let me just stop this by pressing Control C. Please, stop. Okay, yeah, stopped it. Sorry about that. Okay, it's consuming everything from the beginning, so it's going to take a lot. So let me just see, let's close this. So let's say so now, right? So now I have data now being consumed now. So I have data that is being sent. My producer is sending data now to my Postgres database. CDC, that's my database is doing a CDC approach that's picking those data real time as it's being sent to Postgres database to Kafka topic. I just use the command in line interface now to test if I can actually consume data. It's telling me that, oh, I can actually consume data, right? So what I want to do now is I want to write a script that will now pick that data now from Kafka topic and insert it into what's the name now? Into Elasticsearch. So what I'm going to use now is a script called consume to Elasticsearch, right? So this is the script I'll be using, right? So you can see the name of the Kafka topic here. I'll just run this. Everything is actually in our documentation, so you can always try it out. Python consume Elasticsearch the py. So if I run this, right? So it's consuming data now, but data is being sent into Elasticsearch, right? So if you look at the documentation, everything, I actually picked out some necessary values I want to see, right? So let's say I want to know if this data actually exists, right? I can just copy this. I can check it out in so I have a command line. So I'm actually in the WPS. So WPS, I'm using WPS, which is Windows Subsystem for Linux, right? Because what I mean by that, if I open this first, Docker is mainly made for Linux OS, right? So for you to be able to use Docker on Windows, you have to have your WPS installed. So let me just show you something what I did. Let me open the environment variable again. Fabrics, right? And so for me to be able to enter the Linux environments for Docker, I have to come here. So now I'm inside Docker. Let me just let me reduce this a little bit. Okay, level, right? So if I want to check if that what is the name now? Index. So basically, I've actually created an index, right? So how do you create an index? I use a calling script. I'll just show you. So this script, let me just copy the script. Let me open a notepad and show you because I don't start scattering. So let me notepad. Okay. It's on my other screen. Come here. Okay, cool. So in my notepad, right? Why is this? Okay. So in my notepad is a script for creating index. So if I run this script here, so this script now I've created an index called user data index new, right? And the index I've actually mapped it based on the columns I want to get, right? So the columns I want to get are gender, address, latitude, altitude, time zone, email, phone numbers, and I've also kept the data type also there, right? So this is I've actually created an index already, right? So I don't need to create another index, right? So that's where the data is being sent to. But if I want to now confirm if that index exists or not, I can just copy this, right? I'm actually using two screens, so I won't make any mistake. And I'll paste this here. So this, I want to just confirm. I'm using the get query to get if this index exists or not, right? So if I run this, I can show them that, okay, this is the index over here, right? I can also check it the same way too in my Elastic Elasticsearch, right? So this is my visualization, but let me just go to the developer aspect. So the dev tool itself. Okay, this one is basically just okay. This script is basically for me to check out the last 10 records, right? So if I run this, because it's showing me these are records are entering into the database real time. You can see the records are entering. If I run it again, that's change, that's change. You can see now it's showing the records are entering. So that basically means that records are entering into the Elasticsearch. If I run this also, this is just to confirm if the script exists or not. So if I run this, you can see the same thing I did in the Windows terminal I'm also doing here. So you can actually see the same information here, right? So now I know that okay, data is entering into this real time, right? From using the script to consume data from Kafka topic into Elasticsearch index. So I can also check the discovery, right? So if I go to the discovery, so if I go to the discovery aspect, right? So if I say discover, right? So discover is just going to show me all the records that are entering. You can see all the records that are entering, right? If I expand this, I can see the different values and the different table. Okay, so I can see that data are actually entering here. The name of the index is the user new index. You can see the records that are entering. So I can check as many discovery as possible, right? So I can see all the data entering here real time, right? So what I need to now do next is more like, what's the name now? As data is entering here real time, what I was basically need to do now is, okay, let me just go to the dashboard again. That's my dashboard because I've actually created a dashboard, very, very simple dashboard because I don't really have much insights, much records. If I say create new visualization, okay, now so you can see I already have my data here already. But because I've already done all these parts before, right? But if you go through the documentation, I explain how to set up this part, right? Because you have to first pick the file you are trying to use. So let's just say based on gender, for instance, right? If I drop gender here, okay, so let's just change to a pie chart. So you can see, okay, the percentage of male to female XYZ, right? So I can get this information real time, right? So now I can see that you can see that, okay, the whole part of Elasticsearch with Kibana now is working as expected, right? So now let me see refresh. You can see that it's changing because the records are entering now. Because this one was okay, let's notice 51.18. Okay, it changed the other time. Okay, let's say now it's actually 51.1. That means we have more percentage of male to female in the database. So all these are changing real time. Okay, so now the next part where I want us to do next is okay, because my data scientist also wants that data in a file format. So I'm going to send that data now into Data Lake Gen 2, right? I'll send to Data Lake Gen 2 using you can either use the service principal approach where you create an app that connects to your container, that's your Data Lake Gen 2 container, or you can use the SaaS principle. Anyone you prefer using, it works very fine. So I'll go back to my script. So the next script I want to run now is the script that, okay, sorry. So the next script I want to run now is the script for consuming data from Kafka topics to Data Lake Gen 2. So I'll just say Python, right? Run this. And let's see. So now What data now is being sent to data lake Gen. So those data is consuming it from Kafka topic. So if I go to my data lake Gen, so let me go back to my browser. I'll go to my Azure portal. See my Azure portal, you can see the data here, right? What's today's date? Today's 24th, right? And if you look at it, the last time I did it was 28th of what's the name now? August, right? Oh, sorry, September rather, 20th of September, because my subscription finished when I was provisioning to server. I had to now wait to do another one, right? So now, currently, right now, can I say how long I waited after I've actually done this for a very long time, but when subscription finished, I had to just stop and wait again. So now, I have data coming now here real time, right? So this is today. You can see today's date here, right? I've actually tested it earlier, but if I refresh this, I know data are entering here real time, right? So, okay, I think there should be where I can sort. Mm, I'm actually used to using Data Explorer more. Okay, but let's just don't waste time. But data is actually entry. So if I keep loading, let's say, that's how many time I'll need to load. If I need to load more than once, I'll just stop right now. Wow. Okay, yeah, so I've started from today. So this one here is 24th of this month, right? Okay, so you can see now, see the time here, 6:27. So you can see the time, 6:20, 6:28 a.m. So actually, I have to do it very early in the morning before I start work again. So I might not have time when it's by 7, I have to just stop and start my work for the day, my actual work. So I think this partner is working as expected. So let's now go to Power BI. So from the architecture, right? Remember I said, okay, now that the data now comes here, right? So there's a pipeline that picks the data and sends the data into the Lakehouse file folder part, right? You know that the Lakehouse has both this table and also the file system. So I'm sending data into the file system. They call it volume in Databricks or something, right? So I'll go to my Power BI services, right? So okay, let me just show you the pipeline itself. So you see the pipeline first of all. So I go to my workspace, yeah. So in my Fabric workspace, let me look for pipeline. So this is the pipeline, the JSON pipeline, right? But actually, I've not even set, I did set it for incremental, right? But you can actually set for incremental, just use the concept called the last modified date. So you just pick the last modified date from the, you can just set, what you just do basically, you get metadata, you set a loop, and you pick the data based on the last modified date. But because of time and everything, I just don't want to waste my time in all of those aspects, right? But it's very easy to set, so there are multiple ways you can actually set increment. I can actually use a store procedure. You can set based on last modified date, or you can do what we call getting data from the source. Let me see if this aspect has it. Right, where you can set, yeah, you can see the start, you can filter based by UTC now, and also do the add day. You said add day, go back some particular period of day and pick data from the start date, and the end day should be the UTC now. So whatever you want to do, use the dynamic content to do that part. Okay, so basically just picking data from this and sending it to the, so the what this one does it picks data from the source, which is on data lake Gen 2, and sends it to the destination, which is on the Lakehouse file system, right? So if I go back to my workspace, right? So if I go back to my data lake, so if I go back to my Lakehouse rather, so now I can see this is the user file. You can see all the JSON files here, right? So this is how my data scientist wants the data to look like, right? So he now later do his transformation, do his standardization, as converted to a Delta Lake format. So this is a Delta Lake, right? So this is sent as a Delta Lake time, but it's going to be in a tabular format. So it's going to show you how you wrote the script and I did all those parts, right? So now let's now go into the other part. If I go to the architecture, I think so all to this part here has been covered, right? So let's now come to this part here. So I'll go back to this, I'll go back to my fabrics. Okay, so where's my stream analytics? Okay, let me just use one. Okay, so I remember I said something about what's the name now? Because of the way the thing looks like, I can't have, there was a conflict between the Belgium and the CDC for fabrics, right? So when I did it initially, I had to create like two servers, which was custom, so I had to delete it. So what I later did was option 2 was I used a custom app directly. So what is custom app? If I click on this, I'm using a custom app endpoint, right? So I'm using an event up. So what I basically need from here is just two things. I need the key, I need the connection string. I also need so I just copy the connection string. I also copy the event up name, which I now use in this other script. So for this script now, it's called producer to event hub, right? Oh, it's still producing. Okay, cool. Okay, I don't think it's producing. Oh, I was actually worried. Oh, it's just still okay. So now another one now. So I have another script that produces now that sends data real time now to event hub. I'm picking data from that API, right? Now serializing the data and sending those data into the event. I said event hub. Yeah, the event hub connection, right? Send it to the custom app. The custom app is actually event hub. So the beautiful thing about the custom app is that there are multiple approaches. You can either use an event hub, you can use an AMQP, or you can also use Kafka. So this Kafka you can use Kafka approach, which is more like Kafka Confluence, where you get the broker server URL, right? So this one is giving you a URL, but if I was using it on my local machine, on Docker to be local host, but now you can see this one is giving me a normal broker server URL. So any approach, you can either use the Kafka approach or you can use the event stream approach. Anyone works. I'm also for so kind enough that they also gave a sample in JSON, but I think this is in Java actually. So, but I did mine in Python actually. So, is this Python or Java? This is looking more like Java. Yeah, this is Java actually. So, yeah, it's Java. Yeah. Okay, it's Java because I was actually worried. Okay, so they did theirs in Java, or I did mine in Python, but it's still the same thing, Python, Java, whatever language you're comfortable. You can even do it in C# if you're very comfortable writing the .NET frameworks, right? So that's that. So if I was using Kafka, I would have gotten a broker name. But if you notice from the code I used a local host, but I'm setting it from Docker, right? I'm not using a Confluence. I'm not using Kafka Confluence. I'm not using Kafka for Docker, which is on local host, right? So it's not something really, really difficult to use. So for this now, I'll go back to my Python scripts. I'll say Python producer event hub. If I run this, right? So now it's fetching now, it's sending data now to event hub on Fabrics. So if I go back to my event hub, if I check here, right? So now you can see the event hub. So the same, if you are very conversant with event hub in Azure, it's also the same thing as event stream. I'm actually mixing it, and there's so many event hub, event stream, event house. It's actually confusing sometimes, but it's fun though. It's fun actually. So the data format is in JSON. So if I refresh this, I'm just trying to refresh and see if data are entering, right? But let's wait a couple of minutes. All right, it's loading, it's loading. Why are you taking time now? Wow, it's really, really taking time. It is the data inside, right? You can see that it has been off for so very long time, and all of a sudden, I just like, I'm trying to do the recording now. That's what I actually tested everything before. So, okay, awesome, finally. So let's see based on the time. Okay, where is the event process time? So today's 24th. Okay. So I think I'm using, okay, I think yeah, this is correct because for me now, I'm using UTC plus one, but I think this is using UTC, right? So this is 535, 534, and this is 635. So it's actually correct. So for me, I'm using UTC plus one. I'm in Nigeria, Africa. That's the West, Sub-Saharan Africa, right? So I'm using UTC plus one. And for this is UTC, I guess it's UTC. That's why it's actually a 1 hour behind. So it's actually correct. So I can see the data in the event stream, right? So if I go to so this is what we call event house, right? So for my event house, also the same thing, right? So if I go back to my workspace, well, let me just go to event house. So this is my event house where I have my KQL data, that's crucial query database. You can see the entire, just give more like a preview, an overview of the entire system itself. Click on this, right? You can write KQL query. So if you look at now, the last time I actually worked on this was 30th of September. Wow. And when my subscription finished up till this time. So I think I had to now continue again. So this is 24th of August. So you can see how long. That's the time I've actually done the project for a very long time, but I've not had time to complete it, right? Let's see if I create a news table. Okay. Okay, yeah, so you can write KQL queries here. So this is KQL query. That's crucial language. You can write quick here and we can say, oh, projects and do some other things. I think I had some earlier. I don't know if I've removed these. Interesting. Okay, that's fine. Okay, so what we'll do now, let's go to the table itself. This is a custom table itself, right? So for the table, right, I can open Power BI. I can do a visualization, right? Let's see. Let's show any 100 records and see if okay. Okay, yeah. So you can just add, if I want to, I can just add another step and say project, right? I can say, okay, I want to see some particular, what's the name now? Okay, yes, so I can say, okay, uh, these projects, some projects, some columns like name, gender, and gender, address, and let's say coordinates or something called coordinates, right? Okay, cool. Let's see. If I select this, if I run, let's see. I also just see two, you can see now, you can see the column that are coming out. Awesome, cool. So now from this, I can just see it in my Power BI directly. So I can actually do some queries here. I can see it in my Power BI directly, right? So I can see these are the columns I want to see. These are columns I've projected out, right? The names, the gender, XYZ. Let's see. Let me add one more. Let's say email, and phone number. That's phone. So cool. Okay, cool. So run these also. Okay, cool. So I can just open it in Power BI directly. I can say, okay, open in Power BI. So just to preview it in Power BI, how it's going to look like a Power BI preview. Power BI session expired. The current Power BI session can no longer be used to communicate with Power BI because the services. Interesting. Honestly, I don't know why that's coming up, but interesting. Okay, so what I'm going to do now is let's just get a not like a pie chart, right? Let's just add like gender. Well, everyone uses Power BI, so it's not something that should be add, right? I'm editing. Okay, then editing values, right? Count, yeah. So cool. And I can also add like a table here. Table, and I can say, okay, these are the tables I want to see in the database itself, right? So these are the tables I want to see. So I want to see the name. So my name. Remember, all of these are dummy data. They're not real life data, right? So these, just like I was just setting up a table. You're using a matrix or something. Sorry about it. This right and this. So basically now you can see that we're having like a real-time stream project, right, at our hand, right? So you can stream the data real time and get some information from this. So I think I will just stop here, right? So this is all for the streaming part, the engineering part, the visualization part, right? So the other session will be done by my very good friend Dada, who is going to show you how he was able to create an AI model using the OpenAI APIs and building a large language model solution around the data. So you just make our create like a RAG model to ask questions about our data and give us response. So thank you guys. Have fun. Bye.
Hello everyone, my name is Olujare Dada, and I will be taking us through the AI portion of this architecture. The lead architect on this project, Temidayo, already took us through how the data flows from the web application up until the Fabric Lakehouse, and I will just be expounding more on how we leverage AI on the data found in the Fabric Lakehouse. Right, so without much ado, let's dive right in. Okay, moving over to the workspace now. We will be dealing with just two notebooks. That's the Transform and Load notebook and the Delta Table AI Assistant notebook. So let's start with the Transform and Load notebook. Okay, before we begin, it's important for us to know exactly what we want to do before we proceed. The first thing is that we want to transform and load the data. Right now we have the data as JSON files. We want to transform the data and save it as delta tables. And that is what this transform and load notebook would help us achieve. Then the next thing we want to do is to build an AI model, something simple, around the data found on the data table, delta table. So the next thing to do now would be to look for where our data is, right? So Temidayo loaded the data for us into the lakehouse. So we just come over here to lakehouses, then move over to files, then under user folder you can see all the JSON files he has pushed into the lakehouse. So we just wait a moment for the session to start, right? And then we can then begin. Okay, our session has begun, so we can go through the notebook. So the first thing we do is to import all the relevant libraries. So we have the type in for type hints and the datetime, library, as well as the PySpark libraries. Right. Then the next thing we do here is to define a sequence map. So this sequence map just tells us what are the steps being executed by our code, essentially on the data that is found within this user folder. And then we then use this sequence map inside the sequence mapper decorator. So the decorator is going to be used on each and every single function defined in this notebook, and the sequence mapper will just help us understand, okay, what portion of the code or what step is being executed. So let's just run these two cells. So we'll be running each cell as we go to see exactly how the data is being transformed, and we would explain the rationale behind all the steps we're taking. Here I've listed all the functions that would create for the transformation and loading of the data, right? And the first one we'll go through is the read data. So this just basically reads those JSON files and then reads them into a format that we can understand, right? So the data has now been loaded from the file path, the ABFS file path for the user folder, right, which can be obtained when you just copy the ABFS path here, right? If I copy this and paste it, you see it's exactly the same. Now let's examine the payload. So you can see within the JSON files you have the payload, and then you also have the schema. The payload contains the information we're looking for. If you look closely, you can see the name of the person, the date they registered, the latitude, and some other information, right? And then you can also look at the schema, and you see that there isn't much we need here. I don't think we even need anything here at all. It's just the metadata, right? So we can just drop this schema column and make use of just this payload, which is exactly what we do in the next step, which is to extract the payload, right, by dropping the schema, right? So when we do that, we are left with the payload array, right? So this is just an array of dictionaries basically, and now you can see that after the first level of payload we have the after level. After the after level we then have the information we are looking for, which is the address, cell, date of birth, and every other demographic information of all the users in the user folder, right? So now that we know where the data we are looking for is, we can now flatten it, right? So we flatten that array by parsing it with this function. Then let's run this. Now after running this, the array has been parsed now and it has been flattened, and we are viewing just the first element, the first person within the data set. So here it is. Here's the person's information. Now we can then take this information and convert it into a Spark data frame, which is what we do here. We first define the schema, then after that we create the data frame from the parsed payload, right? And that's what we do here. So let's run this. Now after running that, you can see the information is now well formatted in a table. The next steps are the next step will be to capitalize the column, right? So I prefer not to have, all lowercase. I would like to at least capitalize the first letters, right? So run that. Then the next thing, so you can see the names are now capitalized, column names are now capitalized. Next thing will be to parse the timestamps. So here's what I mean by parsing the timestamps. If you look at the date of birth, registered date, and insertion times, they are all timestamp columns. However, it would make more sense for the date of birth and registered date to be date columns, and perhaps the insertion time can be a datetime column. So we achieve this using the parse timestamp function. You can see it's being applied on insertion time, registered date, and the date of birth. Once that is done, we can inspect and see now the date of birth is and the registered date as well as the insertion time are now well formatted. The next step will be to split the time zone. Now the time zone contains two pieces of information. It contains the location of that time zone and then the offset. The offset is just the number of hours or minutes from the GMT, which is the Greenwich Mean Time. So for example, Newfoundland is about 3 hours 30 minutes behind the Greenwich Mean Time. So we want to be able to split this into the time zone location and the time zone offset, which is what we do here. We can inspect this data frame and you can see now it has made the split. At the same time, we also want to be able to filter by this time zone offset. Right now it's in string format, and it would make more sense if we had it in a float or a double, which means we are able to know, okay, we're able to apply functions like max on the column to be able to know, okay, which column is greater, which column has a greater offset than another. Right now as a string, it would be difficult to achieve that. So let's convert that into a float. So which is what this next function does, time zone hours from GMT on this. So if you inspect this, now you can see that Newfoundland, which was 3 hours 30 minutes away from the Greenwich Mean Time, is now 3.5 hours away, right? Which is a float, which makes this filterable now. The next step would be to extract the age. So to extract the age of each individual, we need to go to the date of birth column, right? And then subtract from the current date, right? That is today's date. So when you run this now, you can see now that the age has been extracted. Oh wow, everyone is 54 years old. Okay, then the last step would be to do a final cleanup. The cleanup just involves adding an ingestion date, which is just the current date time, and reordering the columns in a nice and logical way. run this, now we have the data formatted the way we want it and with the ingestion date. Lastly, we just need to write the data frame to a delta table. So when you run this, the name of the delta table is going to be user data. So wait, we get the message data successfully written to user data, right? So that means this user data table has now been created, right? So we can check DBO, then user data, right? So you can see it contains all the columns we just created. Now we then have the run sequence, which just basically combines all the steps that we've discussed so far into one cell and performs everything, performs all the steps. So with that, we've come to the end of this notebook. Now we'll proceed to the AI notebook, the AI assistant notebook. Now we're back in the workspace. Now we just need to open up the AI notebook. Okay, so now we connect to the Spark session. Okay, before we proceed, we need to do a bit of a setup, right? And that is because the version of Azure OpenAI in the default environment, right, is an old version, right? And this doesn't work well with the new Azure OpenAI APIs, right? So right here you can see I've created a new environment, but it's used to be default, right? But I had to create a new one. So you can just come down here, create new environment, right? So clicked on that. So you give the new environment a name, right? And then create, and then it takes you to the new environment. And I think I should just show it, right? So let me just create a test environment here. So test, create. So now we're in the test environment, right? So these are the built-in libraries, right? There's Java, Python, and R. Now what we want are Python libraries, right? So we need to put in the new Python library. So we'll go and get the new OpenAI library, right? So now you can see the version here is 1.5 and above, right? The default version has 0.28, right? So then another thing that we need, another library we need is the .python.env library, right? So those two, right? And then you can just click save and hit publish, right? So we wouldn't, there's no need for me to create this or save or publish this because I already have an environment that works, right? So come back here to our notebook, then continue. Another thing that we need to also do is that we need to, since we are going to be dealing with OpenAI keys, we would need to store those keys in a .env file, right? .env file. So that has been done here as well. So enter into lake houses in my files folder. We open up the config files, right? I think I've already got that opened here. So config files, and then I have two .env files here. One was for when I was testing. So we just store our credentials in the file that we create here. So to create or to upload a file, right, you can just come here, upload files, and then you can just browse on your personal laptop, right? So I have a sample of how this delta AI.env file looks like. So here it is. Right, so you can see you have the endpoint, you have your API key, you have your API version, and you have your model name. Right, so that's how it should look like. Right, and yeah, so with that we should be able to begin pouring through the code. Right, so on the first cell, so that's importing the relevant libraries. So you can see the version of OpenAI we have here is 1.51, and then we can then load the credentials from the .env file. Right, so this is the full file location. Right, so you're able to get this file location. Just come here. To get this file location is the API path, not the APFS path, not the relative path for Spark. This one, API path. Right, so if I paste this here, you'll see, you can see it's exactly the same. So you run this. So you say it's true because it finds it has allocated your values, right? So the next thing you want is to load up your environment variables and store the key values and all. Right, so now that is done, we can then read the data frame that we wrote to the delta table the last time, right, in our user data delta table. Okay, now we have our data fully loaded now. Now we have our table from the previous notebook already loaded up. Now we can proceed to the next step, which is to create our prompt template. No need for a LangChain here. Since it's a simple implementation, we'll just make use of enum classes to create our template. And so what we'll just do here now is we'll create a table schema. So this table schema enum will just explain to the LLM that we have a column named name, and it's of string type, and this is what name means in the table. Right, the same thing for each and every single column within the table. Then the next template we have is the select table template, which basically informs the prompt that it is provided with a table named user table, right? And then it contains the following schema, the schema that we've defined here. And then we then give a sample row within the data, feed it to the LLM so that it understands how the data actually looks like. Then we then tell it to generate a query for us which answers the question, right? And then we will then use that query later on in our code, right? So that is what we expect. That's one of the things we expect the LLM to do. Then we also have this schema, this template, which tells the LLM, again, we have a table and we have this result from that table, and we also have this question, the user question, which resulted in this result, right? So now we want the LLM to summarize this result based off of this query, right? So once the LLM gets the result and also gets the prompt, right, that led to this result, then it's able to give a good summary, right? So, and then we also give the schema, the original schema here to the LLM. Moving on to the functions that help us interact with the LLM, we have first off the get OpenAI client function. So this just helps us get the OpenAI client using our credentials that we loaded earlier on. Then we also have this instruction type select function. So this basically helps us to select or to choose which instruction types we want to execute. Remember, we have the summarize table, which tells the LLM to summarize the results of a query, and then select table, which tells the LLM to generate a query for us. So those are two sets of instructions. So we need this function here to help us select which of those two functions will be required. Right, then we then have the generate instruction function. So this right here uses this function here, right? So basically the way it works is, if there is a prompt result, so okay, let me start like this. This function takes in the prompt, takes in the table name, also takes in the prompt result. Now this prompt result is the result here in the summarize table, right? So if we are trying to just generate a query for the first at the onset, we are trying to create a query at the onset, we wouldn't need this prompt result, which is why it is defaulted to none, right? So if it is none, then it implies that this prompt result is like we are not yet going to need the prompt result, meaning that we are probably trying to generate a query, right? So since that is the case, we then come here to say, okay, if not prompt result, it implies that, okay, prompt result is none, right? Then we can then select the instruction type to be the select, right? So to select this one, the select table, and then the instruction will just be this, all this, right? So we then pass in the prompt, pass in the table, and then pass in the table schema. If the prompt result is an empty dictionary, right, that implies that perhaps there was an issue somewhere and there was no prompt available or something, right? And that led to, I think I even have that here. So bad prompt error. So no data frame generated. This might be due to a bad prompt check GPT response variable, right? So just in case, just covering all the bases here. And lastly, if there is actually a prompt result here, right, and it's not none, and it's also not an empty dictionary, then it implies that we're trying to summarize, right? And then we just come here and pick the summarize template, and then pass in the variables that it requires as well, right? So that's how this works. So this generates the full set of instructions that we're going to pass to the LLM, and then we then have this get GPT response. So this basically takes in the instructions generated by this function, and then, so here it is here, and then if the instruction is a bad template instruction, right, bad prompt error that we created in the enum class, right, it should just return that error so that we can see it, right? Else it should pass that instruction to the LLM, and then we expect the result. After this, we also have the parse GPT response. So once the response is back, we also need to parse it. We cannot just use it directly because some extra characters, spaces might have been imputed, and so we cater for that, by stripping of new line characters, SQL, new line, tab space, and the backtick, right? And then we have the generate GPT data frame. So this function here just generates a data frame from the parsed response, which is the query that we got back from the LLM, right? Then we then convert the GPT data frame to dictionary. So this GPT data frame that we generate here, we convert it to a dictionary. So that it's that dictionary now that is passed into the summarize table template as this prompt result. So now, after that, we can then just simply test our query response, right? Just test how everything works together now. So first of all, we have this prompt, right? Then we also have, we get the OpenAI client, we get the GPT response, we parse that response, right? After parsing that response, we then pass that parsed response into this data frame to generate the GPT data frame. Then afterwards, we then convert that data frame into a dictionary and then ask the LLM to give us a summary of the data, right? So let's run this cell now. So yeah, so now it's done. So let's check the summary first, right? So run that. You can see that it works fine, and then it tells us, gives us the answer to our query. Then the table, right, the data frame that it generates, here it is, right? And with that, we've come to the end of this notebook. Thank you for listening so far. Really appreciate it. Enjoy the rest of your day.